Hello students, welcome back to my channel. Now to begin with the problems on differentiation, you need to know all these formulae which I have given you in the last session. So make sure that you have written all this formula. Okay, along with this we have got one more formula, that is algebra of differentiable functions. This also you need to know before we start our problem. So this is the algebra of differentiable functions, which again we have seen in the last class. Okay, so here we have to differentiate the following with respect to x. So all these questions we have to differentiate with respect to x. Okay, and here if you see in all the questions the variable is x. Okay, here a means a constant. Fine. So let us begin with the first problem, that is this one. So question says differentiate the following function. Now I'm going to consider this as y. So you have to write let y equals to whatever is given, that is x to the power 200 minus 5 x to the power minus 4 plus 3 4 5 6. Okay, 6 zeros are there. So you want to differentiate with this with respect to x. So you have to write differentiating both sides with respect to x. Okay, so when you differentiate y, then you'll have dy by dx. So equals to there, equals to, now if you see only this one, this is x to the power n, and if you differentiate this one, or let me write the full thing for once, so d by dx of x to the power 200. Okay, now minus 5 is a constant, so it can be taken outside, so d by dx of x to the power minus 4. Okay, plus now d by dx of this is a constant which will be 0. Okay, now let us simplify this further. So you have x to the power n can be written as n, that is this one, x to the power n minus 1, that is 200 minus 1, which is 199. Okay, now as usual this is my n, so n is minus 4 here, so the differentiation of this becomes n x to the power n minus 1. So n is minus 4. So minus 4 and minus 5 will get multiplied to get minus into minus becomes plus. So 5 into 4 is 20. Okay, and the differentiation of this is x to the power n minus 1. That is n is minus 4. That is minus 4 minus 1, which is minus 5. So this is my answer for first one. Now let us have a look at this next question. So next question is this one. Now if you are able to solve or simplify the given expression, that will be very nice. Okay, but if you are not able to, then you have to directly do like this. Okay, so you have to differentiate each and every term. But here if I call root x as a and this as b, then this looks somewhat like this: a plus b whole square plus a minus b whole square, and we have got direct formula for this, which is equals to 2a square plus b square. So this is the direct formula. So let me apply this formula. So again I'll write let y equals to whatever is given, so you will write whatever is given, and this is equals to 2a squared. Okay, so what is a for me? A is root x, so root x squared plus b squared, and what is b for me? B is 1 by root x, so b is 1 by root x. So that means from here what am I getting? From here I am getting y equals to 2 into root x squared is x plus this is 1 by x. So this is my y. Now let me differentiate this one. I can further simplify this and write this as x plus x to the power minus 1, because 1 by x can be written as x to the power minus 1. So again you will write differentiating both sides with respect to x. Then if you write that, you have dy by dx is equals to, now let me take this outside. Okay, so we have d by dx of x plus d by dx of x to the power minus 1. Okay, is that clear? Okay, now differentiation of x is how much? 1. Okay, now this is my n for me. X to the power minus 1 is there, so minus 1 is n for me. So differentiation of x to the power minus 1 will be, or x to the power n will be, n into x to the power n minus 1. So n is minus 1 out here, so minus 1 gives me minus 2. So this will be equals to, so only this part will be equals to minus x to the power minus 2. So that's why it can be written as 2 into, okay, so this is 1. So 1 and minus is there, and x to the power minus 2 can be written as 1 by x square. So my dy by dx is 2 into 1 minus x square. Okay, now let us have a look at this particular problem. Okay, so again as usual I'm going to call this as y. So let y is equals to x squared sine x. Now here if you see, there is a product of two different kind of function. Okay, so this is my f and this is my g. Okay, and we know that when we differentiate both sides with respect to x, then here we'll get dy by dx. But here what happens, according to the formula, that is this one, according to this third formula, then we have to keep one of them as constant and differentiate the other. Okay, and whichever is differentiated in the next case, I will keep them as constant and I'll differentiate the other one. Okay, so we'll make use of this one in this. So we have, okay, so if I call this as f and if I call this as g, then I have f should be constant, so f is x squared, so I need to differentiate g, that is sine x. So d by dx of sine x. Now you will put plus sign, and now g will be kept as it is, so g will be kept as it is, that is sine x, and I'll differentiate the other one which was kept constant earlier, so that is I'll differentiate x squared. Okay, now let us simplify this further. Now this is x squared into, now differentiation of sine x is cos x. Okay, now plus sine x is there, and this is x to the power n again, so n is 2, so it will be 2 into x to the power n minus 1, that's 2 minus 1 is 1, so it will remain as it is. So let me keep it in proper format. So we have x squared cos x plus 2x can be written in front, so 2x sine x. So this is the answer for this particular function. Now let's differentiate this particular function. So we have y equals to a to the power x sec x. Again here also we have got two functions, product of two functions. So let me call this as f and let me call this as g. Then if I do that, so again you have to write differentiating both sides with respect to x. Now if I differentiate both sides with respect to x, then I have to keep one of them as constant and I have to differentiate the other like this way. So I have differentiation of y is dy by dx, so a to the power x is kept as it is, so we will differentiate sec x, plus now we'll keep sec x as it is and we'll differentiate a to the power x, dy by dx of a to the power x. Now a to the power x, so differentiation of sec x is sec x tan x. So all this I'm writing from the given formula. Now sec x into, now differentiation of a to the power x is a to the power x log with the base e a. So this is the formula. So let me keep this a to the power x as a to the power x and sec x as common. Then I can write this as a to the power x sec x. So we have tan x, and from here we have log a to the base e. So this is the answer. So pause the video to note down. Okay, now in these two questions we need to find the derivatives, and here we have function of the form f by g, and this is also kind of f by g. Okay, now let me write this as y equals to 1 minus cos x by 1 plus cos x. Okay, so this is my f and this is my g, and our formula says, or our property says, that whenever we have f by g, then we'll first write the square of the denominator in the denominator. Okay, and we'll follow this pattern. So let's see how to do this. Now this is my f and this is my g. This whole thing is my f, this whole thing is my g. Now again, as usual, we will write differentiating both sides with respect to x. Now after differentiating, you have dy by dx is equals to, now we have denominator squared. So we have in denominator 1 plus cos x, so we'll write 1 plus cos x whole square. Okay, now whichever is squared just now, that has to be kept constant, and we will differentiate the numerator. So g, that is 1 plus cos x, will remain as it is, and we will differentiate the numerator, and numerator is 1 minus cos x. Fine. So there's a minus sign here, so we'll write minus. Now we have got f, so f is this one, so we'll write f 1 minus cos x, and we'll differentiate g, so that is d by dx of g. G is how much? G is 1 plus cos x. Okay, now let's differentiate these two. So we have 1 plus cos x. So when I differentiate 1, I'll get 0. Sine is minus out there. Okay, and differentiation of cos is minus sign. So minus sign and this minus becomes plus. So we have sine x minus. So we have 1 minus cos x here, and differentiation of 1 is again 0, plus, and differentiation of cos x is minus. So minus into plus is again minus. So let me write minus out there. So we have sine x. Is that clear? Divided by 1 plus cos x whole square. Now let us simplify this. Now this is 0 plus sine x is sine x. So sine x into 1 is sine x, plus sine x into cos x is sine x cos x, minus is there. Okay, so this minus into minus becomes plus. So sine x into 1 is sine x. So plus is the plus is the sign. Here we have got minus sign. So sine x into cos x is sine x cos x whole divided by 1 plus cos x whole square. Clearly this and this gets cancelled out there, and we have sine x plus sine x is 2 sine x by 1 plus cos x whole square. So this is my answer for this particular problem. Now the second part, there's this question, you will give it a try by yourself. Okay, your answer will be mentioned in the description. So pause the video to note down. Okay, now let us have a look at this particular sum. The question says, if s is equals to ut plus half ft square, find ds by dt. when t is equals to 2. So this problem has been taken from your class 11 physics. Okay, so S stands for distance, U stands for initial velocity, D stands for time, F stands for acceleration. Okay, so you need to find ds by dt, that is the velocity when time is equals to 2. Okay, so let's see how to do this. So S is given to be this much, so let me call this as 1, or you can directly write given S equals to ut plus half ft squared, then you will write differentiating both sides with respect to t, because here the variable is t, right? So differentiating both sides with respect to t, let's see what happens over there. Now when you differentiate, this becomes ds by dt. Okay, now u, the initial velocity, u is initial velocity, so u is initial velocity, and initial velocity is always constant, so this can be kept as it is, and we have to differentiate t, and we have d by dt of t. Okay, so u is constant, that's why it is kept outside. Now sine is plus, so again acceleration is also uniform. Okay, so in this case we take uniform acceleration, that means acceleration is constant, and half is also constant, so that's why this will be kept outside, and we will differentiate only t square, so d by dt of t square. Now let's see how much it is. Now we have u into, now d by dt of t is 1, okay, plus half f, now this is t square. Okay, so d by dx of x square is 2x, right? So similarly it will be 2t. Now t and t gets cancelled, so we have u into 1 is u, plus, so here only f and t are left, so f into t is ft. Okay, now question says find ds by dt when t is equals to 0. So therefore ds by dt when t is equals to 2 is given by, so wherever is t in ds by dt, so we have ds by dt equals to this much, so instead of this t I am going to put 2. Okay, so we have u plus 2 into f is 2f, so my answer is u plus 2f. Okay, now similarly let's have a look at this question. So question says if y is equals to this much, so we need to prove this. So here we have got dy by dx, so we will find dy by dx from here. So we have differentiating both sides with respect to, now the variable is x, right? So we'll write with respect to x, then we'll get dy by dx, differentiation of y is dy by dx, and this is again f by g form, right? So f by g means we have in the denominator this square, right? So denominator is square, that is x plus 4 square. Now in the numerator, first I'll keep it as it is, so x plus 4, and I'll differentiate the numerator, so dy by dx of x. Now we'll write minus, now whichever is differentiated that will be kept as it is, and whichever was not differentiated will differentiate that, that is x plus 4. Now let us simplify this further. So we have x plus 4, so differentiation of x with respect to x is 1 minus x. Now differentiation of x is again 1, right? Plus what is differentiation of constant? It is 0. So we have in the denominator x plus 4 whole square. So similarly we have, let's open the bracket, so we have x plus 4. Okay, so x plus 4 into 1 is x plus 4 minus 1 plus 0 is 1, so 1 into x is x by x plus 4 whole square. Okay, now x and x gets cancelled, so you have 4 by x plus 4 whole square. So this is the value of my dy by dx. Now let us see what happens in the left hand side. Okay, so we have left hand side equals to x dy by dx. So let us put the values and see. So we have x into dy by dx is 4 by x plus 4 whole square. So when I multiply these two, 4 and x gives me 4x, and in the denominator we have x plus 4 whole square. So this is my left hand side. Now similarly, let's find what is my right hand side. So right hand side contains y into 1 minus y. So let us put the value of y. So from here, y is equals to x by x plus 4. Okay, 1 minus y is x by x plus 4. Simplify this further. So x by x plus 4 is there. Now here the LCM is x plus 4. So x plus 4 into 1 is x plus 4. Minus is there, so we have got x out there. So again x and x gets cancelled. So 4 into x is 4x by x plus 4 into x plus 4 is x plus 4 whole square. So I got left hand side to be this much and my right hand side is also this much. So similarly, therefore left hand side is equals to right hand side. So with this we have proved this part. Okay, so pause the video to note down. Now let us simplify this question in the very same way. So y is given to be a by x, and remember this a is a constant. So here the only variable is x because we are differentiating here with respect to x. Okay, so we'll write given y equals to a by x, then we'll write differentiating both sides with respect to the variable is x. So that's why we'll write with respect to x. Now differentiation y is dy by dx. This a is constant, so that's why it can be kept outside. So we will differentiate 1 by x, because when a is kept outside then we have 1 by x. So d by dx of 1 by x, right? Now this can be written as a into d by dx of x to the power minus 1, because 1 by x is x to the power minus 1. Now this minus 1 is n for me. Okay, so differentiation of x to the power n is, this is as it is, so x to the power n is n x to the power n minus 1, right? So when you simplify this, you will get how much? Okay, so minus 1 into a is minus a, right? And this is x to the power minus 2, which is actually by x square. Okay, so this is my dy by dx. I hope you are clear with this. Now let's check what is my left hand side. So we have therefore y by x plus dy by dx. Let us simplify this. Now how much is y? Y is a by x, and with this it becomes a by x square. And what is the value of dy by dx? It is minus a by x square. So both are same, so both will get cancelled. So ultimately you will get 0. So we have shown this as well. Now let us try to understand this particular question. Question says, so there's a curve y equals to x plus 1 by x. Okay, now we need to find the points on the curve, this one, where dy by dx is 0. Now let us try to understand what is the meaning of this particular question. Now when we started our differentiation or derivatives, that time I said dy by dx gives you the tangent, slope of the tangent to the given curve. Okay, so similarly here what is happening is there's a curve. So there's a curve. Okay, so let me call this curve to you y equals to x plus 1 by x. Now you need to find the points on this curve. Okay, so it can be either here, here, or anywhere on the curve. So we have to find the points where dy by dx is equals to 0. That means dy by dx is what? Slope of the tangent. So that means slope of the tangent to be 0. Now this means that the tangent is parallel to x-axis, because from your class 11 coordinate geometry you might have learned that the lines which are parallel to x-axis, will have slope to be 0. Okay, and as dy by dx represents slope, so that's why my tangents would look somewhat like this. So the question is asking what is the coordinate of this point, and here also the tangent is parallel, so what is the coordinate of this point? So that's what the question is asking. Okay, so let's see how to do this. So first and foremost we need to find dy by dx. Okay, so given is y equals to x plus 1 by x. Okay, now differentiating both sides with respect to x, then this can be written as dy by dx equals to, and what is differentiation of, okay, so we'll write it plus, so differentiation of this plus differentiation of 1 by x, and we know that differentiation of x is 1, and just now we saw that differentiation of 1 by x will be how much? From here it is minus 1 by this x to the power minus 2 comes down, so minus 1 by x square, so plus minus 1 by x square, so plus is here, and differentiation of this much is minus 1 by x square, so open the bracket, so plus into minus is minus. Okay, so this is the value of your dy by dx. Now according to question dy by dx is how much? It is 0, right? So let us put the value of dy by dx. So dy by dx is how much? 1 minus 1 by x square, so this equals to 0. Let me take this over there, so we have 1 equals to 1 by x square. Let's do cross multiplication, so 1 into x square is x square equals to 1 is there, so therefore the value of x will be, now since I am writing only x instead of x square, I need to put square root sign, and whenever we take square root we will have two signs, that is plus minus, and what is square root of 1? It is 1. Okay, now we got the value of x, so that means we have founded this distance. Okay, so to find coordinates of this point, so we have got abscissa and ordinate, so this x values gives you abscissa, so now we need to find the ordinates. Okay, so we have founded this abscissa and we have founded this abscissa, so we need to find the ordinates. Now let us find the ordinates. Now we have two cases, when x is equals to 1, because we have got plus minus 1, so I am taking 1. So if I call this as equation 1, then from 1 let us see what do we get. So we have y equals to x plus 1 by x, so what is the value of x? It is 1 plus 1 by 1, and if you simplify this, how much will you get? 2, right? So whenever x is 1, the value of y is 2. Okay, so similarly we'll see what happens when x is equals to minus 1, so other value is minus 1. So again from 1 we have y equals to x is minus 1 plus 1 by minus 1, so plus into minus becomes minus, so I'll get this much. Simplify this, you'll get minus 2. Okay, so at last you'll write, therefore the points on the curve is this one, so I can call this curve 1, where dy by dx is equals to 0 are, so what are the points? It will be 1 comma 2, so whenever x is 1, the value of y is 2, so it is 1 comma 2, and other one is minus 1 comma minus 2 and minus 1 comma minus 2. So pause the video to note down. Now let us start the new topic for today, that is chain rule. Now in chain rule we find the derivatives of composite functions. Now we have already talked about composition of functions in continuity class. Okay, so the definition for chain rule is somewhat like this. Okay, so let us not go into the definition because it's very difficult to understand, not so difficult, but it will be difficult one to understand this particular definition. Okay, so we'll directly try to see the problems, because once you see the problem, then the rest of the problems are going to be very easy. Now question says differentiate the following with respect to x. Okay, now again as usual I'm going to consider this full thing to be y, this is also going to be my y, and how to solve this, let's have a look at this. So again let me call this let y equals to, okay, so you will do that and we will write differentiating both sides with respect to x. So when I do that, then this y becomes dy by dx. Now what strategy you are going to follow here is you will try to work from outside. Okay, so you will work from outside and you will go inside. Okay, so outside what do we have? We have got power. So treat this full thing as x, so it will be x to the power n. So the differentiation of x to the power n will be n into x to the power n minus 1, right? Okay, so what is n for me? N is minus half. So what is x for me? So this is 3x squared minus 9x plus 7, and n into x to the power n minus 1. So n is again minus half. Okay, now we have just worked with the power, but we have not differentiated this part. Okay, now since we have worked with outside part, now we'll go to the inside part, and inside we have got this one. Now we will differentiate the inside part. So d by dx of 3x squared minus 9x plus 7. So this is there inside this. Now let us simplify this one. So we have minus half. So this is 3x squared minus 9x plus 7, and this is minus half minus 1, which is minus 3 by 2. Now let us differentiate this one. So this 3 will remain as it is. Now we need to differentiate x squared, and we know that the differentiation of x squared is 2x. So we have got minus 9 out there, and differentiation of x is 1, plus is there plus, and differentiation of 7 is a constant, so that's why it will be 0. Now let's simplify this further. So we have minus half can be written as it is. So we have 3x squared minus 9x plus 7 to the power 3 by 2 into, now this is 3 into 2 is 6x minus 9. Okay, so this is my answer for this particular problem. Now let us have a look at this problem. So again I'm going to consider this to be y, so let y equals to this much. Now again differentiating both sides with respect to x. Okay, so whenever you are differentiating this, y becomes dy by dx. Okay, now first and foremost we have got into out there, right? Yes, so this is one function f and this is another function g. So f into g. So f into g gives me, first keep it as it is, differentiate this, plus keep it as it is, differentiate this. So e to the power 5x into d by dx of log sec x. Okay, now we'll write plus and we'll keep it as it is. So log sec x is there, and we'll differentiate e to the power 5x. Okay, now this is equals to e to the power 5x into, now as I said we'll work from outside because there are two functions again. So log sec x, okay, there is no into sign here. This full thing is a composition of two functions. Okay, one is log x and another is sec x. Okay, now when we differentiate log, because we have to work from outside as I said, so when I differentiate log x I'll get 1 by x. So let me call this as x. So if I differentiate log, then I'll get 1 by x, and x is sec x. Okay, now next what you will do is, there's an into sign there, so we'll write into. Now what is differentiation of sec x? It is sec x tan x. Have you understood? Let me repeat once again. So differentiation of log will be 1 by x, and x is sec x for me. Now into will differentiate sec, we are going inside, so differentiation of sec x is sec x tan x. Okay, now similarly we have log sec x. Now what is differentiation of e to the power x? It will be e to the power x itself, so e to the power x itself is there, but we have to differentiate this as well now. Okay, so what is differentiation of 5x? So 5 will be kept outside and differentiation of x will be 1, so that's why only 5 will be left. Here sec x and sec x are getting cancelled, so here e to the power 5x can be kept common, so e to the power 5x is common, so here what is left? Only tan x is left, plus here we have got 5 log sec x. Okay, so this is our answer. So pause the video to note down. Okay, so before we move on to the next question, I would like to remind you one thing which I have not said in the beginning session, that this x in trigonometric functions, whatever x are there, okay, so all this x represents angle. Okay, now all these angles are with respect to radian measurement. Okay, so all these are radian measurements, not degree. Okay, so that means whenever you see degree, and if you want to differentiate that, first you need to convert that into radian. Okay, and all of us know that 1 degree can be written as pi by 180 radian. Okay, so with that we'll start our next problem. Okay, so we need to differentiate this using chain rule. Okay, so as usual I am going to call this to be my y, so let me write, so differentiating both sides with respect to x, but as I said, we have got x degree out there, so we need to convert this into radian. So let us convert. So this can be written as log sine. Okay, so 1 degree is equals to pi by 180, so that's why x degree will be pi by 180 into x, that will be pi x by 180 radian. Okay, so this is my y. Now since I am differentiating with respect to x on both sides, this becomes dy by dx. Okay, and as I said, in chain rule we have to come from outside. Okay, so from outside we will go inside, so outside is log. So if I call this as x, then I have log x, and differentiation of log x is 1 by x, and how much is x? X is sine pi x by 180. So this is differentiation of this log. Now we need to do into, right? We need to keep on multiplying. Now let us differentiate sine. So differentiation of sine is cos, right? So it will be cos this one, so pi x by 180 into, now we have to go again inside, because inside we have this whole chunk, right? So pi by 180 is constant, so if I want to differentiate this pi by 180 can be kept outside, so pi by 180 is kept outside, so we need to ultimately differentiate x. So let us differentiate x. Okay, and what is differentiation of x? It is 1, right? Okay, so this is pi by 180 only, so d by dx of x is only 1, so this full thing becomes 1. So we have 1 into pi by 180 is pi by 180 degree, 80. Okay, into is there. Now this cos pi x by 180 can be written as cos x degree, right? By we have got similarly sine, this can be written as x degree, and this is equals to pi by 180 into, this is how much? This is cot x degree. Hope you have understood the sum. Okay, now similarly let us go to question number 5. So again this is my y, so I'm not writing further, that you have to write this by yourself. Differentiating both sides with respect to x, you will write by yourself. Now when I differentiate, I will get dy by dx. So this is separate sum. So dy by dx is equals to, this is my power outside, so let us first differentiate the power. So this is in fact this to the power half, right? So this full thing will go here. So this is my n and this is my x, so it will be n x to the power n minus 1, that is half, minus 1. Okay, so we have here 1 plus log x into log of sine x. Okay, now we have just differentiated the power. Now let us go inside. Now we need to differentiate this one, so we need to differentiate d by dx of 1 plus log x into log of sine x. Okay, so this is power minus half, so when it goes down the power becomes plus, so this can be written as in fact 1 by 2 square root of the same thing, 1 plus log x into log of sine x. So this can be, this much can be written in this way, into, so we have into d by dx of 1 is 0, right? Now let us differentiate this one. So we have got the product of two functions here. So we have this one as one function, let me call this as f, and this is another function, and let me call this to be g. Okay, now let us differentiate product of two functions. Now whenever we differentiate product of two functions, what we do is we'll first keep one function as constant. So let me keep log x as constant, and we need to differentiate the rest one, that is dy by dx of log of sine x. Now what next, we have to put plus sign. Now whichever was not differentiated earlier, that will be differentiated next one, and whichever was differentiated, that will be kept as it is. So we have log of sine x kept as it is, and we need to now differentiate log x. Okay, simplify this. So after simplifying, let's see what do we get. So whatever is there in this full thing, you will write as it is here, plus this is 0, so I don't need to do anything with 0, so it vanishes. Now log x is there, log x into d by dx, that means differentiation of log of sine x. Now if I call this as my x, then it is log x, and differentiation of log x is 1 by x, and what is x? It is sine x, into, now I need to differentiate sine, right? Because we are working from outside to inside, so we have differentiated log, and now we need to differentiate sine. So differentiation of sine is cos. Okay, plus sign is there, plus, now log of sine x is there, and what is differentiation of log x? It is into 1 by x. Is that clear? So what you can do here is, you can simplify this, you can write this as cos by sine, which is again cot. You can do that, okay, and you can just simplify it further. So this also gives you the answer. Okay, now let us have a look at this particular question. So again, this is my y equals to this much. Okay, so you will write all this differentiating both sides with respect to x, all these things you will write by yourself. So let us directly start. So dy by dx can be written as, okay, so if I call this as x, because tan something is there, so differentiation of tan is sec squared x, and what is the value of x? X is log sine e to the power x squared. So this is about tan. Now let us go inside. So when I go inside, I will get log, so this becomes my x. Now into differentiation of log is 1 by x, and what is x here? Sine of e to the power x squared. Okay, into, now we'll move further inside. So sine is there, so differentiation of sine is cos. And what is x? X is e to the power x square into, now inside sine there is exponential, so e to the power x is, what is differentiation of e to the power x? It is again e to the power x. And what is the value of x? It is x square. Now let us move to the power. We have just differentiated the exponential part, now we will go to the power. So in power we have d by dx of x square. So d by dx of x square is how much? It is 2x. Okay, now you can simplify this further. Again you can write this as, okay, so let me write this 2x e to the power x in front. So 2x e to the power x square. Again this is cos by sine, so cos by sine can be written as cot e to the power x square, and at last we'll write sec square log sine e to the power x square. So this is the differentiation of this particular function. Now the last one, it is y equals to cos inverse, cos of sine inverse of something. Okay, now let us do the same way here. So differentiating both sides with respect to x here is constant. Okay, so again when you differentiate, you will get dy by dx. Differentiation of cos is minus sine, so minus sine of, this is my x, so cos x, so sine x becomes sine inverse of x by a. So we have just differentiated cos function. Now we'll go to inside function, that is inner function is sine inverse. And what is the differentiation of sine? It is 1 by root over 1 minus x square. And what is x here? It is x by a, so that's why it will be x by a whole square. Now we have differentiated sine inverse. Now we'll go to the last function, that is x by a. So in x by a, 1 by a is constant, right? 1 by a is constant, so 1 by a can be kept outside. Now let us differentiate the only remaining part, that is x, so dy by dx of x. And what is the value of dy by dx of x? It is equals to 1. Now again sine of sine inverse, so sine and sine inverse both gets cancelled, so only x by a is left. So minus x by a 1 by root of 1 minus, this is x square by a square into 1 by a. Simplify this further, so you'll get minus, okay, x into 1 is x, into 1 is again x, right? We have a into a is a square. Now when you simplify this, you have a square minus x square, and in the denominator still will be having a square. Now square root of a square is a, and that a goes to the numerator and becomes this much. So this and this gets cancelled, so what will be left? Minus x by a, only 1 a is left, okay, into a square minus x square. So this is my answer. So pause the video to note down.